Okay. So in this problem it says an air traffic controller observes two airplanes approaching the airport. The displacement from the control tower to plane 1 is given by vector A, which has a magnitude of 220 kilometers and points at 32 degrees north of west. So let's just label our vectors here. Vector A, 220 kilometers at 32 degrees north of west. And the displacement from the control tower to plane 2 is given by the vector B, which has a magnitude of 140 kilometers. 140 kilometers. And points at 65 degrees east of north. Now, that's just your book being tricky, and that's not really the direction we like expressed. We don't say, oh yeah, I'm gonna travel 12 miles east-north. No, you say 12 miles northeast. Okay, this would be an angle measure that's relative to the vertical. We don't like that. We like our angles measured relative to the horizontal. That way all of our equations for components and such are still valid. So immediately switch that from 65 degrees east of north to 25 degrees north of east. That means the exact same direction, but put it in terms of the measure between the vector and the horizontal axis. So 140 kilometers at 25 degrees north of east. So it says sketch the vectors A, negative B, and the vector D, which is the combination of A and negative B. So we're going to need negative B here, so let's just quickly label what vector negative B would be like. So negative B is B, same magnitude, just in the exact opposite direction. So negative B would be 140 kilometers at 25 degrees south of west. So, let's draw A. Let's draw negative B. So A is 220 kilometers north of west, 32 degrees north of west, something like that. Actually, let's draw this over this way a bit. 32 degrees north of west. 220 kilometers. Then negative B is 140 kilometers, 25 degrees south of west. So south of west would be, there's west, 20 degrees south of it would be something like that. So 20 degrees. And about 140 kilometers or so. So here we have negative B, and here we have vector A. And so vector D, which is A minus B, the combination of A and negative B, will be drawn from the tail of the first to the head of the last. So here is the vector D is equal to A minus B. Okay? So we accomplished the first part. We drew all three vectors. And again, since it's A and B, A and negative B that we want to combine, those are the ones that get drawn head to tail. Then B, it says use components to find the magnitude and direction of vector D. So we're going to have to break this vector down and this vector down into its two components, add the x components to the other x components, add the y components to the other y components. So when we do that, that's when we make a chart. So our chart's going to look like this. We got our x components, got our y components. We're going to combine vector A and vector negative B. And that combination are going to give us the components of vector D. So vector A, its components, 220 cosine of 32. Since it's going west, that's going to wind up being negative. And its y component is going to be 220 sine of 32. And that's north, so that's going to wind up being positive. Vector negative B is going to be 140 cosine of 25. That's also going to be negative when we plug that in. And 140 sine of 25. And that's south, so that's going to be negative 2. So quickly plugging into our calculators, what those are going to be. So we plugged in our components into the calculator there. Add this column, add this column. So negative 187 plus negative 127 would be negative 314 and 117. Let's do that here really quick. (117) plus negative 59 is positive 58. So these are the two components of our resultant. Now just always double check ourselves before we go on and do the Pythagorean theorem. Look at this component, and look at the resultant vector that you drew. Looking at this resultant vector, does this resultant vector look like it should have a comparatively large negative x component? Yes. Does it also look like it should have a comparatively small positive y component? Yes, because it's very wide horizontally, but not so tall. So this one way that we can kind of double check what we did here, make sure we didn't forget a negative or a positive somewhere to make sure that our answer makes sense. So once you get to this point, then to finish the problem, we got to do Pythagorean. So the magnitude of d is equal to the square root of 314 squared plus 58 squared. And our angle is going to be equal to the inverse tangent of the y component, 58, over the x component, 314. And again, plugging that in really quick. 4 squared, 58 squared. So magnitude is 319 kilometers at an angle of about 10 degrees, and that's going to be 10 degrees northwest. North because of the positive y, west because of the negative x component.